may seem strange and even frightening to some. Well, in China, that is exactly what's now being tested.
Something big is brewing on the wide blue ocean. China has pushed past old ship ideas and launched a new class of water vehicles that leave experts stunned. These new crafts slice through waves, slip beneath the surface, and carry heavy loads. Quite unbelievable. They run on hydrogen, methanol, and even nuclear power in early tests. They promise to change trade, travel, and even naval power. What does all this mean for the United States? Riding the dragon's wake. China first revealed its new Blue Whale craft at the Zhuhai shipyard on April 28, 2025. At first glance, it looks like a long, sleek speedboat painted in ocean blue. However, beneath its smooth hull lies a complex system that lets it move on the surface or slip under the waves like a small submarine. Engineers from China Media Group built the Blue Whale to run on its own. They packed it with cameras, sonar, radar, and an advanced computer that guides every move. On the surface, water jet thrusters shoot streams of water backward, pushing the vessel forward at speeds above 25 knots. To dive, the craft uses ballast tanks that fill with water within seconds. Once submerged, electric pods turn slowly to make almost no noise. This dual mode lets the Blue Whale switch from fast surface runs to near-silent underwater patrols without a crew. Its dive depth reaches about 200 meters, deep enough for many surveys but still shy of ocean trench levels. The heart of the vessel is its mission computer. It takes in live feeds from 5 high-definition cameras around the hull. Sonar pulses scan ahead for obstacles. Radar sweeps warn of ships on the surface. All this data goes to the onboard processor. It makes decisions on steering, speed, and depth. If the system spots a large ship, it automatically slows or changes course. If it senses a threat, it can surface fast or hold position underwater. Tests showed 9 days of continuous work. In that time, the Blue Whale covered more than 1,500 kilometers and surfaced only for recharging solar panels and a small diesel generator. That hybrid power mix means longer missions without needing to dock. Solar panels on its deck charge batteries during daylight. At night, a diesel unit keeps essential systems running. Engineers say this blend cuts fuel use by nearly half compared to a manned ship on similar missions. Inside, payload slots can be swapped for extra equipment. One day, the craft carried side-scan sonar to map the sea floor. The next day, technicians fitted small rescue pods loaded with first aid kits and life jackets. In tests, crews reconfigured the vessel in under 2 hours. That speed makes it ready for new missions without complex dry dock work. Cost is another advantage. Building each Blue Whale costs under $20 million. A single crewed research vessel can top $100 million once you add living quarters, safety systems, and a larger crew. China's state shipping line has already ordered 10 for trials along the South China Sea. Private firms in Singapore and Norway are said to be watching closely, eyeing purchases for offshore wind farm surveys and undersea cable checks. Even so, challenges remain. The dive depth of 200 meters limits some scientific studies, such as deep-sea biology or oil well inspections. Battery technology still caps underwater endurance at about 24 hours per dive. Heavy storms can confuse the craft's sensors, forcing it to pause missions. To fix this, engineers plan software upgrades and stronger hull materials. Full sea trials will run through 2026 to iron out weaknesses in rough waters. China is already working on a larger model. Early blueprints show a version twice as long, carrying more fuel, and diving twice as deep. That craft could spend weeks at sea, scanning wide areas or serving as a communications relay for other drones. If tests succeed, China could have the world's first mass-produced fleet of deep-diving autonomous vessels. Experts in the United States have taken note. America's unmanned ship programs, such as the medium-displacement unmanned surface vehicle, lack undersea capability. United States naval planners worry that Blue Whale drones could skirt coastal defenses, map sensitive areas or shadow naval exercises without detection. Some suggest building competing drones in Gulf Coast shipyards. Others recommend investing in better anti-drone sonar and patrols. For now, the blue whale stands as proof that low-cost autonomy can change sea operations. It blurs the line between a patrol boat, a survey vessel, and a drone submarine. Whether used for science, rescue, or surveillance, this craft signals a new era in water transport. As China pushes forward, other nations must decide: catch up, collaborate, or risk falling behind on the deep blue frontier. But what makes the blue whale truly terrifying isn't just what it can do above water, it's what it silently does below. Let's dive into its hidden power, the sea's silent sentinel. When the blue whale slips beneath the waves, it turns nearly invisible. Engineers shaped its hull with special angles and smooth panels to cut down on drag and the noise that hull-riding craft usually make. Inside, slow-spin electric pods replace the water jets used on the surface. These pods whisper through the water, making less than 45 decibels at 50 meters, quieter than a light rain. That unmatched silence lets the craft move under ships, around oil platforms, or above cable lines without alerting anyone. Beyond its stealth hulls and silent engines, the blue whale is filled with a suite of sensors tuned for hidden work. Its primary tool is side-scan sonar, which sweeps two fan-shaped beams side to side. As these beams bounce off the seafloor or structures, the onboard computer stacks the echoes into a clear, grayscale map. In tests, the sonar traced pipelines buried under 10 meters of silt and located metal wreckage scattered over a square kilometer. Crews call this undersea X-ray because it lets them see through layers of mud and debris. Alongside sonar, magnetic anomaly detectors run non-stop. These sensors watch for tiny shifts in Earth's magnetic field caused by steel objects. In one drill, off Hainan Island, a blue whale detected the hull plate from a sunken patrol boat hidden in a coral canyon. It marked the exact spot on its map, guiding divers to the wreck within hours. That same mission would have taken days using towed magnetometers or manned submersibles. Infrared cameras give another view. Even underwater, heat leaks from machinery or vents on shipwrecks. The blue whale's thermal sensors pick up these faint signatures, highlighting engine rooms, hot exhaust ports, or warm vents on deep-sea gas fields. In an exercise near the Bohai Sea, the drone surveyed an offshore rig's underwater pipes. It spotted a small leak by sensing a warm plume of water escaping from a joint. Operators fixed the leak before it could grow into an environmental hazard. Combine these tools, and the blue whale becomes a roving, silent eye below the waves. In one mixed-use mission, a single vessel scanned 40 kilometers of the seabed by day, then at night used infrared to check warm water vents near hydrothermal fields. That broad sweep of data, sonar maps, magnetic logs, and thermal images arrived back at the base within minutes of surfacing. Data teams say this rapid turnaround beats existing survey ships by a factor of 5. The drone's stealth also shows in real-world drills. In May 2025, 2 blue whales staged a mock reconnaissance off Guangdong's coast. They slipped past a flotilla of patrol boats, dove past netted fisheries, and surfaced beside a simulated cargo vessel without a single warning shot or radio alert. Observers tracked their paths on satellite, but admitted no on-scene unit detected them. That exercise proved how easily these crafts can operate under the cover of darkness or heavy traffic. Civilian groups see huge promise. Offshore wind companies need regular checks on turbine foundations, sometimes buried deep. Sending a crewed vessel with divers costs tens of thousands per day and risks safety in rough weather. A blue whale can slip in, map the base with sonar, drop a small camera pod, and leave all in one silent run. Pipeline operators agree. Monitoring hundreds of kilometers of undersea pipe for cracks or anchor drag becomes practical when a drone can handle long missions alone. but the military angle drives the biggest headlines. In the South China Sea, where rival claims overlap, the blue whale's ability to gather unreported data alarms neighbors. Reports from independent trackers show these drones near reefs claimed by Vietnam and the Philippines. Beijing insists they stay in Chinese territorial waters, yet no local patrol has logged an intercept. That gap raises questions about sovereignty and early warning defenses. Compared to the United States drone vessels, the blue whale has the upper hand underwater. America's Sea Hunter class stays on the surface. It can track ships or drop sonar buoys, but must stay above waves. Other United States prototypes, like tethered submersibles, need cables back to a mothership. The blue whale goes fully untethered. No lines, no mothership, so that it can slip deeper and farther. To keep data flowing, the drone uses low-frequency radio when submerged. That reaches shore stations up to 20 kilometers away. For longer hops, it surfaces shortly to link via secure satellite. With solar panels charging by day and a small generator for night, it can stay out for 2 weeks at a time. China aims to mass-produce 50 of these stealth sentinels by 2028. Shipyards in Shenzhen and Shanghai are converting assembly lines. Engineers also plan a larger model that dives to 400 meters, cruises 1,000 kilometers, and carries extra sensor pods. If successful, China will set the pace for silent undersea drones. As these crafts spread, navies, researchers, and companies worldwide watch closely. Stealth, detailed mapping, and long missions open new possibilities and new worries under the waves. The blue whale has given China a silent sentinel at sea. Now the rest of the world must decide how to listen. Hydrogen high roads. On May 10, 2025, shipbuilders in Jiaxing, Zhejiang province launched the Dongfang Qinggang container ship powered by hydrogen fuel cells. This vessel marks a shift in maritime transport. It uses hydrogen and a battery pack to spin its propellers. The launch ceremony drew officials and engineers. They called the ship a test for zero-emission shipping on China's inland waterways. The ship stores hydrogen in metal hydride tanks. These tanks hold gas at high pressure, even under rough conditions. Each tank sits inside a steel shell with sensors to detect leaks. When the vessel needs power, the system releases hydrogen from the tanks. The hydrogen flows into fuel cell stacks where it reacts with oxygen. That reaction creates electricity and water vapor. Inside the fuel cell stacks, hydrogen splits into protons and electrons. The electrons flow quietly along an electric circuit to drive the ship's motors. Protons pass through a membrane to join oxygen. Together they form water. The system runs reliably and continuously as long as it contains hydrogen and oxygen. It is cleaner than burning diesel fuel. To boost performance, the ship also carries lithium batteries. They store extra electricity produced by the fuel cells. During peak power use, the batteries send current to the motors. When power demand falls, the fuel cells recharge the batteries. This two-way flow helps maintain a steady speed. It also prevents fuel cells from being pushed too hard. On its first voyage, Dongfang Qinggang sailed 400 kilometers along the Grand Canal. It departed Jiapu port near Shanghai with 150 containers. Crews measured speed and fuel use. The ship averaged 12 knots, matching diesel vessels. Engineers timed refueling at 2 inland stations. Each stop took under 3 hours. That turn shows that hydrogen can work on canal routes. The ship's hydrogen tanks held 100 tons of gas. With batteries, the ship reached a range of 800 kilometers before refueling. Refueling stations are scarce beyond Zhejiang and Jiangsu. To fix this, the ports plan to use mobile hydrogen trailers. Trucks will dock beside the ship to pump gas. Engineers believe these trailers can cut refuel time to 2 hours. China's government gave $30 million in subsidies for this project. Officials see inland shipping as key to cutting carbon. Over 10,000 freight vessels move goods on the country's rivers and canals. A fleet of hydrogen ships could reduce air pollution in cities, including Hangzhou and Suzhou. Local leaders have backed clean energy trials to improve health and meet climate goals. Safety was a top concern. Hydrogen can ignite if it leaks. The shipyard built double containment systems around the tanks. Sensors monitor for tiny leaks. If a leak appears, automatic vents open to release gas high above the deck. Crew members train weekly on emergency drills. They perform leak tests, practice vent activation, and inspect seals to keep the system safe. Environmental experts note that gains depend on how hydrogen is made. If it comes from renewable power, the ship's carbon footprint drops to near zero. If hydrogen comes from coal or natural gas, the benefit fades. China plans more wind and solar plants to supply clean hydrogen. Experts say linking green energy and fuel cells is the best path to emission cuts. Private firms have joined the trial. A Shenzhen energy group plans to run passenger ferries on hydrogen to avoid diesel fumes in crowded harbors. Farmers in Anhui province speak of hydrogen barges to ship grain. They say cleaner fuel may bring a price premium for crops. Shipyards in Wuhan and Chengdu have begun bidding to build more vessels if the pilot succeeds. Despite early gains, the ship faces hurdles. Green hydrogen costs more than diesel at present. Building new refueling stations can be costly and slow. Layers of regulation govern safety and port permits. Engineers must adapt the design for larger ocean routes. That work could take years. Dongfang Qinggang stands as proof that hydrogen can power container ships today. China plans more hydrogen trials in other provinces. Projects are under study on the Yangtze River and Pearl River Delta. Engineers aim to build a fleet of 20 ships by 2027. Each vessel will refine its design and lower costs. If successful, inland shipping on clean fuel could spread across Asia. Efforts could change how goods move on rivers and canals. However, hydrogen's not the only game changer. Another fuel is already making waves, quietly, cleanly, and across thousands of kilometers. Meet the Minhu, a hybrid workhorse rewriting the rules of river shipping. Fuel of change. On February 12, 2025, the Minhu set off from Shanghai's Waigaoqiao terminal at first light. Carrying 1,800 tons of cargo, it traveled more than 1,900 kilometers inland along the Yangtze River to Chongqing. This vessel uses a dual-fuel engine that burns methanol and diesel. Crew members start the engine with diesel fuel and then introduce methanol as the speed rises. Methanol burns cleaner than diesel, offering lower emissions. Sensors inside monitor the fuel mix and temperature, keeping the engine running safely. Flames inside the combustion chamber glow softly, showing the twin fuels working together. Ship designers chose a German engine maker to modify a standard marine motor for dual fuel. Engineers altered fuel injectors and pumps to handle methanol's lighter nature. The engine control system blends fuel by reading pressure and flow. Methanol enters chambers through special lines with heating elements to keep the fuel at the correct temperature. Diesel remains available to stabilize the mix under heavy load. When carrying heavy containers, the ship held a speed of 12 knots. The fuel economy improved by 15% compared to diesel only, saving both fuel costs and emissions. Methanol tanks on Minhu hold 2,500 cubic meters. These tanks sit inside sealed pods and protect the fuel from seawater. Ports along the Yangtze built new refueling stations. Each station uses trucks with high-pressure pumps to fill the ship. Crews complete refueling in under 4 hours. On one trip, Minhu ran 800 kilometers before returning to dock. Mobile refueling trailers proved that on-site gas delivery can work. China plans more mobile units to serve remote ports. Expanding this network is key to the wider use of methanol fuel. Government incentives help the project. The Ministry of Transport offered subsidies covering half the extra cost of a diesel ship. That cut the price gap and encouraged owners to join trials. Environmental groups supported the plan. They noted that each switch to methanol cuts sulfur oxide by 90% and nitrogen oxide by 50%. Government leaders in Chongqing said the cleaner fuel could reduce winter haze in the city's basin. Activists pressed for full monitoring of emissions to ensure real gains. Shipbuilders see domestic and foreign orders if the pilot succeeds. Safety drove design changes. Methanol is toxic if leaked. The ship's engine room has vapor detectors in every compartment. An automatic vent system opens ducts to send gas well above the deck. Valve seals use special polymers that resist methanol's effect. Crew members drill monthly on leak response and emergency shutdowns. Fire suppression systems line the engine room walls. Control panels show tight zones of high energy. Engineers added double-layer piping and redundant sensors to prevent single failures. These steps let operators run the craft with confidence. Shipyards in Wuhan and Chengdu have bid to build similar dual-fuel vessels after seeing Minhu's success. Plans include larger hulls for up to 3,000 tons of cargo. Engineers study ways to use methanol made from renewable sources. Green methanol uses captured carbon dioxide and wind power to produce fuel. That process can cut the vessel's true carbon footprint to nearly zero. Companies in Europe and South Korea have asked to test similar ships on their rivers. These international partnerships could speed up low-carbon shipping worldwide. Despite progress, the methanol engine faces challenges. Producing enough green methanol requires large renewable plants. Building refueling stations across inland routes will take years. Regulatory reviews of safety and ports can delay new ships. The cost of methanol must fall below that of diesel to drive wider use. Engineers plan to improve engine efficiency and lower production costs. Universities and research institutes in China study better catalysts and fuel blends. If these efforts succeed, inland shipping could shift toward cleaner energy, transforming an era of Asia's rivers and canals. Barges at dawn. Along China's long coastline, 5 new amphibious barges have slowly taken shape. Unlike typical flat-bottomed ships that rely on cranes or shallow docks, these vessels ride on retractable wheels. When floating, they move like standard barges. As they near shore, crew members lower heavy-duty hydraulic legs and wheel assemblies from recessed compartments. The wheels extend downward until they contact the firm ground below. Then, the onboard diesel-electric motors engage the wheels, allowing the barge to roll directly onto beaches or hard docks without any cranes or external equipment. Each barge measures 90 meters long and 20 meters wide. Their steel hulls hold up to 500 tons of cargo. Designers fitted the deck with tie-down points and locking rails to secure heavy loads. In tests at the Ningbo mechanical plant, crews loaded light tanks, construction vehicles, and large crates onto the barges. They drove across sandpits, gravel ramps, and soft mud near the Pearl River Delta. The wheels handled uneven ground at speeds up to 10 kilometers per hour, fast enough to roll heavy gear onto shore before roads reopened. The hydraulic system relies on a bank of pistons and high-pressure pumps powered by a diesel-electric generator. When the captain flips a control switch, hydraulic fluid surges through steel lines to the wheel blocks. Each piston lifts or lowers with exact pressure. Sensors monitor ground contact and adjust pressure to avoid sinking. If the wheels detect unstable terrain, an automatic safety routine halts movement and raises the wheels back into the hull. That feature prevents damage to both the barge and the shore structure. In a simulated flood relief exercise in Guangdong province, these barges showed their value for humanitarian aid. Crews loaded emergency shelters, water purification units, and medical supplies onto a barge. They rolled ashore past broken docks and directly deposited goods on a flooded beach. Relief teams praised the speed and flexibility compared to unloading at broken harbors, trucking materials over damaged roads, and then rebuilding supply lines. By dawn, villagers had vital resources delivered in a single, smooth operation. Military analysts note strategic potential as well. These barges could carry armored vehicles such as the ZTD-05 amphibious assault tank or troop transport modules onto islands lacking ports. With no cranes needed, Forces can deploy quickly at first light before enemy radar detects large ships. In regions like the South China Sea, lightly defended reefs might see sudden landings with little warning. That scenario alarms neighboring countries and raises questions about rapid island defense. Shipyards in Ningbo and Guangzhou have begun production of 5 more barges, and they are planning to deliver 20 units by 2027. Each new barge will feature improved wheel assemblies and stronger hull plating for rougher beaches. Designers are also exploring electric drive options for quieter, low-emission land runs. They hope to replace the diesel generator with high-capacity battery packs in the next model. If successful, this change could reduce local air pollution when operating near towns or relief camps. Durability and safety are crucial for these hybrid vessels. Engineers coated welded joints and wheel parts with anti-corrosion alloys that resist saltwater damage. Maintenance crews have to inspect seals and pistons every week. They flush hydraulic lines with fresh water after coastal missions to clear salt and sand. Crew members follow strict checklists before each shore operation, testing wheel deployment and wheel drive systems. That routine minimizes breakdowns and keeps the barge mission ready. Beyond China's borders, foreign companies watch closely. Norway's offshore energy sector seeks similar craft for wind turbine installation on remote coasts. Singapore port operators imagine barges delivering containers to new land reclamation sites. On Arctic coasts, where ice blocks shallow ports in summer, amphibious barges could open new trade routes without building costly docks. International interest may drive exports and joint development projects. Despite the promise, challenges remain. Beach gradients vary widely, and an incline that is too steep can stall wheel motors. Soft sand or clay can still trap heavy barges if the ground is unstable. Engineers must map shore sites ahead of operations and adjust cargo weight accordingly. Training pilots to interpret ground sensors and hydraulic feedback is vital. Long-term field tests will run through 2026 to refine sensor systems, wheel designs, and shore approach procedures. By dawn's early light, these amphibious barges offer new ways to move heavy gear from sea to shore. Whether supplying disaster relief, building coastal infrastructure, or supporting military landings, they show how China is pushing water transport into new terrain. Other nations now face a choice: develop similar vessels or watch impressive landings unfold unopposed. While China tests its tech on shifting sands, America's not just watching, it's game planning. Behind closed doors, Pentagon strategists are mapping a response to the rising tide of innovation. Waves in Washington. On the other side of the Pacific, United States defense offices have turned their eyes toward China's new watercraft. In May 2025, the Congressional Research Service released a study titled "China's Autonomous Future at Sea." The report highlighted the Blue Whale drone and other developments as milestones in unmanned marine technology. It noted that these low-cost vessels could challenge the United States Navy's existing edge in undersea and surface operations. At the Naval War College in Newport, Rhode Island, analysts studied scenarios for using similar drones. They discussed sending small fleets of unmanned craft to scout ahead of aircraft carriers or to monitor remote shipping lanes. The college held war games where drone teams mapped coastal areas without alerting the opposing side. Participants noted that the Chinese craft's stealth and depth capacity gave them a distinct advantage over existing United States surface drones. The United States Navy's unmanned surface vessels, such as the Sea Hunter, lack diving ability. Sea Hunter can stay at sea for weeks, tracking ships and dropping sonar buoys. It cannot submerge. Other United States prototypes rely on tether lines to dive, which limits their range and exposes the mothership. In contrast, the Blue Whale moves freely underwater, gathering data without cables or support vessels. At the same time, the United States Army Corps of Engineers watched China's methanol vessels and hydrogen ships. They manage inland waterways and must meet clean air rules. While America's rivers see less self-propelled traffic, the court is curious if methanol or hydrogen could serve tugboats and dredgers. They sent teams to China to study trials on the Yangtze River, and test dual-fuel engines. Budget plans began to shift. In June 2025, leaders in Congress proposed a $1 billion ocean technology fund. The goal was to back American drone vessels, fuel cell research, and amphibious transports. Supporters argued that United States builders could win back the lead if given enough funding. Opponents warned that spreading money across too many projects could dilute results and slow progress in key areas. Public discussions followed. Headlines on defense websites asked, "Can the United States catch up?" And "Is clean fuel the next arms race?" Journalists noted that America led in unmanned research only a few years ago. Now, the question was whether the United States yards and labs could match China's fast prototypes and mass production methods. Many articles cited America's complex approval processes as a potential drag on innovation. The Environmental Protection Agency and Coast Guard also took note. China's hydrogen and methanol trials promised cleaner air and water. The Coast Guard reached out to Chinese partners for joint tests on fuel cell vessels and exhaust filters. These experiments aim to tackle shared threats such as oil spills, marine debris, and emissions in busy ports. At sea, the United States Navy held exercises with Sea Hunter and underwater drones tethered to support ships. They practiced mapping deep channels and tracking dummy targets. Officials noted that adding submersible, untethered vessels would require new designs, budgets, and safety reviews before they could sail. That process often takes years. Marine Corps planners also warned about China's amphibious barges. These wheeled vessels could deliver tanks onto small coral islands before larger ships arrived. The Philippines and Vietnam raised concerns at talks, calling on the United States to step up patrols. In June, the House Armed Services Committee held hearings where a three-star admiral explained that Chinese prototypes force new defense plans. At universities like MIT and Woods Hole, researchers started projects on clean fuel ships and drones. NOAA scientists joined to test storm mapping, marine life tracking, and international maritime safety. These studies explore how low-emission, autonomous vessels can monitor ocean currents, track weather systems, and study sea life with possible benefits for both security and science. In the end, American planners must decide how fast to move. China has shown it can build, test, and scale bold new vessels quickly. The United States often moves through budget votes, environmental reviews, and safety checks. The path ahead will test whether America can adapt as fast as it must to remain a leader on the world's waters. Thank you for watching today's video. What will America choose to do next? What are your thoughts on China's new generation water transport? Share your thoughts in the comments below.